Hey everyone, welcome to my channel. I am Khan Madam and I am a lecturer by profession with a passion of teaching. Join me on this channel, Physics by Khan Madam, for a relaxed and supportive learning environment where we explore physics as a subject together. Before we start, I would like to inform you that we are starting from the basics of physics and we will study gradually and steadily move forward to more complex topics as well. These lecture series specifically will be more helpful for the students studying in 11th standard, having CBSE Board or Maharashtra State Board as well. Okay, let's start with our lecture series. First and foremost, let us discuss the topic that we will be studying. We will start with unit number 1 of standard 11th. Okay, so in this chapter what we will study about unit and measurements, and in this particular unit we will study about dimensional analysis, how we can use dimensional analysis to verify that our units are correct or not. Okay, so this is the crux of this particular unit. In this chapter we will study about fundamental and derived units and dimensional analysis and everything around it. Now, what is unit? You may have heard this terminology units or unit in almost day-to-day life. So what is unit? Listen, from a very long time humans started trading as a means of living. So to measure or calibrate the amount of substance or things that they are exchanging within the transaction, there used to be units. For instance, one sack of wheat in return of few chips of gold or so. But with time, when this trading came into existence at global level, there were need of some universally accepted parameter. Then there comes the need of unit. So unit can be defined as measurement of any physical quantity involves comparison with a certain basic, arbitrary, chosen and internationally accepted reference standard. So this is what unit can be defined as, or unit is basically measurement of any physical quantity which is universally accepted. So examples of a unit can be given as length. For meters, for length we use meter as its unit, for time we use second as its unit, and for mass we use kilogram as its unit. Okay, so these are the units you may have heard in day-to-day life. Now there are different system of unit for distance, mass and time. Okay, so in earlier days scientists from different countries were using different system for unit for measurement. There are three systems that they were using. First is CGS system, in which unit of distance is measured in centimeter, mass in grams and times in second. Another similar type of system was MKS system, where distance was measured in terms of meter, mass in terms of kilogram and time in terms of seconds. And third and mostly used type of system is known as an FPS system, which is foot, pound and second kind of system. Okay, so these were the three kinds of a unit or dimensional system that people were using. But for international level, what we have done, in 14th International General Conference on Weights and Measure recommended the use of International System of Unit, and this International System of Unit is known as SI unit. And what is SI unit? SI unit is basically a system of units which is universally accepted, and SI unit is nothing but a MKS system, that is meter, kilogram and second system. Okay, so if someone asks you what is SI system is nothing but MKS system, which is meter, kilogram and second. Now we know why MKS system at global level. Let us dig deep into this unit. There are few fundamental quantities like distance, okay, mass, time and temperature. Okay, temperature. There are few quantities that are basic quantities, right? So these basic quantities makes the base or core of another quantities. What I'm saying is that there are few fundamental quantities that are basic parameter to measure other different quantities. So depending upon the nature of quantity, there are two types of unit. Okay, So there are two types of unit, that is fundamental unit and derived unit. Now what is fundamental unit? Fundamental unit are those unit that doesn't need any other quantity to define them. Okay, so we already learned what is SI unit. It is MGS unit, and there are 7 fundamental SI unit or 7 fundamental units that can be used to define another quantities. So what are those 7 fundamental units? That is length, mass, time, temperature, electric current, luminous intensity, amount of a substance. So another type of unit is known as derived unit or derived quantity. So what is derived quantity? The unit of for any other physical quantity that can be expressed as combination of base quantity. Now what are the examples of derived quantity? For instance, let us consider the velocity. Velocity is defined as displacement per unit time. Now we know that displacement is a base quantity, time is a base quantity. So we have defined velocity with the use of two base quantities or two base unit. Hence our velocity become a derived quantity. Okay, derived unit. Similar goes for momentum. Momentum is nothing but product of mass and velocity. So these particular momentum become a derived quantity since we are using mass, which is a base quantity or base unit, and velocity, which is a base unit. Okay, so this is how derived unit are defined. So derived unit are those units that need any other physical quantity. In this case, any other physical quantity was mass, any other physical quantity was velocity to define our initial unit. Okay, now we have studied up till now that what is unit, why it is studied, and why it is important. We have studied that there are 3 types of system, unit system: CGS, MKS and FPS, out of which MKS is considered to be a universally or internationally accepted kind of system. Now there are another 2 kinds of unit which are known as supplementary unit. Okay, they are considered to be a fundamental unit, but they are known as supplementary unit. So beside the 7 fundamental unit, there are 2 more units called as supplementary unit. Now what are these 2 supplementary unit? Okay, if you are considering 2D structure like in XY plane, so here we have plane angle. Now consider a cake which you are cutting in a cone shape. So if you are looking perpendicular to this cake, you are seeing that you are able to see there is a circle which is cut down in a triangle. Okay, similarly, this plane angle defines the arc length of a circle to the radius. The ratio of these 2 quantities is nothing but a plane angle. Plane angle is denoted by d theta, and it is d theta equals to ds upon r. The unit of this d theta is nothing but radian. Now from very long time, I would say from 10th or 9th standard, we know that how to convert radian to degrees and degrees to radian. 1 radian is nothing but 180 by pi, and 1 degree is nothing but pi by 180. Okay, you are cutting it, but you are observing it parallel to the line. Okay, parallel to the cutting line. Now you will see there is a cone shape structure, right? There is a cone shape structure. So solid angle is nothing but a ratio of surface area of portion of sphere to the square of a radius of sphere. Now you have to make sure one thing, that when we were discussing the plane angle, we are considering only the radius of a circle, but when considering the solid angle, we are considering the square of a radius of a circle. So the formula changes to d omega dA by r square. So you have defined supplementary unit in 2D plane angle, in 3D solid angle, and solid angle is defined or denoted by d omega. Okay, so this is how we have studied about types of unit. Now there are different examples of derived unit here I have given. Before that, just to make sure that you are having a good basic to study physics, I have made small tip or trick, whatever you want to say. This is a triangle. Okay, whenever you want to study or want to recall, how will you define speed, how will you define time, how will you define distance? So what you will do, you will draw a triangle, make 3 sections out of this triangle, write S, D and T. Okay, if If you want to define S, it is nothing but the ratio of d upon t. D is nothing but distance upon time. If you want to define distance, it is nothing but product of speed into time. If you want to define time, it is nothing but ratio of distance upon speed. Okay, so this is the basic formulas. Now if you want to define speed is nothing but distance upon time, so this is how, okay, this is distance upon time. Velocity is nothing but displacement upon time. Now what is displacement? Displacement is nothing but the distance between final point and initial point. The distance between final point and initial point is known as displacement, and acceleration is nothing but change in velocity upon time. Now if you know few basic formulas like mass upon volume for density, then mass upon acceleration for force, so on and so forth, you can literally derive the unit out of that formula. For instance, if you consider an area, can be defined as length into breadth. Length is nothing but a distance, breadth is nothing but a distance. So it is, we know that distance are measured in meters, so it is nothing but meter square. Now if you consider a volume is nothing but length into breadth into height, again which is meter into meter into meter, which will be a meter cube. Similarly goes for density, mass upon volume. Mass is defined in terms of kg, volume in terms of meter cube. So we can, similar goes for acceleration, which is velocity upon time. Pressure is nothing but force upon area. Now before defining force upon area, you have to define what is force. Force is nothing but mass and the ratio of mass and acceleration. Force is nothing but the ratio of mass and acceleration. So we have already defined mass as in kg, acceleration you have defined as meter per second square. So this kg per meter second square can be known as Newton. Similar goes for another derived quantity. So you have to go through it. Like pressure is nothing but force upon area. Force is defined in terms of Newton. Area is defined in terms of meter square. So Newton. Meter square inverse is nothing but Pascal. So instead of using multiple times, what we do, instead of using this Newton per meter square or kg per meter square, we will use Pascal, Newton. For energy or work done, you have used the formula. We know that work done can be defined as force into distance. So it is nothing but Newton meter, and Newton meter is nothing but joules. So these all are an SI unit. Power is nothing but work done into time. We know that work done can be defined in terms of joule. So joule per time is nothing but joule per second, which is watt. Voltage can be defined as work done per unit charge. So it is joule per charge, which is Q, and this can be joule per charge can be defined as volt. And you have to know, you would also know that charge can be defined as current into time. So you define the charge by Q, but you define the current by I. So this is a basic difference you have to keep in mind, that whenever you want to describe the charge, you are using the term Q or symbol Q, and whenever you are explaining the current, you are using the symbol capital I. So this is I into T can be known as Coulomb. So in this particular lecture, this first lecture of our series, what we have studied the concept of unit, two types of unit, fundamental unit. There are seven fundamental units and derived units. Again, beside from two fundamental units, there are two supplementary units. For 2D there is plane angle, for 3D there is solid angle. For plane angle we have a formula, length of an arc of a circle to the radius of a circle. And for solid angle we have a formula, surface area of a portion of a sphere and square of a radius. You can consider it as a sphere. Right, you're considering this as a sphere, and this is a conical portion that you're cutting out of it, and this particular angle is known as a solid angle. It is very useful for your further studies. Okay, till then we will discuss more in upcoming lecture what is dimension and dimensional analysis. Up till, keep studying, take care of yourself, bye bye.